guys, in this video we're going to take a cheeky little peek at how to simplify surd terms. So a question might ask you to express a surd in its simplest form, or it might ask you to express a surd in this form here, m root n, or any combination of two letters. So let's have a look at how we do just that. So the two surd rules that we're going to use here, we're going to use the fact that root a, b, can be written as root a times root b. That's our most useful chap for this. But we're also going to use the fact that root a is equal to a. So the square root of a number times the square root of the same number is just equal to that number. So this is one of those areas of maths where there's so many different ways sometimes of doing the same question. So where this is true, I'll run through a couple methods on the same question. Okay, so let's check out the first example then. Root 27. Now ideally, what we need to try and think of is a square number that goes into 27. So if we think about the factors of 27, we're quite limited. We've got 1 and 27, or we've got 3 and 9. Which is really useful to us because 9 is a square number. So we can write root 27 as root 9 root 3. Now the reason that we've done that is that 9 is a square number, so we can nicely square root 9, and that will give us 3 root 3. So root 27 in its simplified form is 3 times root 3. 3 root 3. Job's a good one. Okay, root 45. Again, if we go through our factors of 45, we've got 1 and 45. Not useful. We've got 3 and 15. Now, neither of those are a square number. That could help us, though. We'll run through how that would work for us. But we've also got 5 and 9. So again, 9 is a square number, so we can write root 45 as root 9 root 5, because 9 times 5 is 45. Now we can square root 9 again. So the square root of 9 is 3, and that will leave us with 3 root 5. If, as I mentioned, we went for, let's change colour to show it's a different method. If we went for root 3 and root 15, then what's going to happen? We've got root 3, root 15. Now there's nothing that we can do there. 3 and 15, neither one of them are square numbers. But what we can do then is split root 15 into root 3, root 5, because 3 times 5 is 15. And now we've got root 3 times root 3. So these root 3 at the start are going to become a normal 3, then give us 3 root 5 again. So, same question, same answer, two different methods. Okay, root 54. So again, the square number that goes into 54 is 9. So we can write root 54 as root 9 root 6. And then the square root of 9, 3 root 6. Job's a good one. Okay, root 48. So this is one that has quite a few different methods. So the most direct route would be if we spot that 16 goes into 48, and it goes in 3 times, so we can write root 48 as root 16 root 3, and then the square root of 16 is 4. So we're going to be left with 4 root 3. Let's take a peek at another method. So we might spot, well, 48 is even. I can't think of any square numbers to go into it. But let's see what happens if we take out a factor of 2. So let's write root 48 as root 2 root 24. Now we can do that because 2 times 24 is 48. Now there's nothing there that we can do to get rid of a surd. But again, 24 is even. So we can take out another root 2. So 24 is equal, root 24 is equal to root 2 root 12. So now we've got root 2 root 2 root 12. So the root 2 can become 2. Then we got 2 root 12. Now, how do we know if we have actually reached our final answer? Well, there will be no more simplifying that we can do underneath the third term. So we might be looking at 12 and thinking, are we there or are we not there? But really, while you're getting used to it, just practice and see what happens. So again, even if we didn't spot that 4 goes into 12, we might just spot that again, it's an even number. So we could write this as 2 root 6. Because root 12 we can write as root 2 root 6. Now we can't simplify root 2 or root 6 separately, but what we can do with root 6 is write it as root 2 root 3. So then we've got 2 times root 2 root 3. Now that root 2 in the middle, again, is going to become a nice normal 2. So what we've got here is 2 times 2, root 3. So 4, root 3 again. Okay, let's look at the next one. Root 72. This one's a beauty. Loads of different ways to do this one. So we'll check out one or two. So the most direct route would be to spot that 36 goes into 72 2 times. So we can write root 72 as root 36 root 2, and then the square root of 36 is going to give us 6 root 2. We might also spot that we could write root 72 as root 9 root 8, because 9 times 8 is 72. Now we can express root 9 as 3, so we've got 3 root 8. Now is there a square factor inside 8? Yes there is, there's 4. So we can now write 3 root 8 as 3 root 4 root 2. Now we know the square root of 4 is 2, so we've got 3 times 2 root 2, so we've got 6 root 2. Cool. Okay, root 99. Now there's not very much that goes into 99. We've either got 1 and 99, 3 and 33, or 9 and 11. So again, the most direct route then would be to write root 99 as root 9 root 11, and then the square root of 9 is 3, so we get 3 root 11. Let's say we went down the 33 route, and we said that root 99 was equal to root 3 root 33. Then we can write root 33 as root 3 root 11. So now we've got root 3 root 11, root 3 is 3. So we're left with 3 root 11. Okay, one more, root 50. Okay, so there's really not very much we can do with 50. We've either got 1 and 50, 2 and 25, or 5 and 10. So the most direct route would be 2 and 25, so we could write root 50 as root 25 root 2, and then the square root of 25 is going to leave us with 5 root 2. Let's go down a different route, so let's say we were going to go for root 5 root 10. Then root 10 we can write as root 5 root 2. And now this root 5 is just going to leave us with a nice normal 5, lots of root 2. Okay guys, that's how we simplify third terms. Hope it's useful.